Hello friends, welcome to our chemistry class again today. We are here to continue from where we stopped in our last class. Before now, in some of those previous classes that we had, we have been dealing with electrolysis. We have been talking about electrolysis of different substances, sodium chloride using different electrodes. We saw what happened at the anode and the cathode and the electrolyte, copper 2 tetraoxosulfate 6, the same thing. We talked also about electrolysis of acidified water. Today, we are going to move away from that aspect into Faraday's first law of electrolysis. Faraday's first law of electrolysis. What does it say? The law states that the mass m of an element discharged during an electrolysis is directly proportional to the quantity of the electricity Q passing through it. Now, we are going to carry out some calculations under this first law of electrolysis. But before we start that, what I want you to note, very important, if you don't note these three things, you may find it difficult to do calculation under electrolysis. Now, the first one is what? That Q equal to IT. What is Q? Q is quantity of electricity. I is current of a current passing through the system. T is time taken for that current to flow through it. Note that that's point number one, and this is a formula connecting them. Number two, note also that E minus equal to 1 Faraday equal to 96,500 Coulomb. What is E minus? We have been talking about it in electrolysis and so on before now. So E minus is electron. That means 1 mole of electron is equal to 1 Faraday of electricity, and the value of that is 96,500 Coulomb. Note that. Another point that you have to note is how to write balanced half equations. When you know how to write balanced half equations, things will be easier for you. But if you don't, go and learn that from some of those classes that I taught before now. Now let's see this problem. Example 1. Calculate the time required to deposit 1.6 gram of copper from copper 2 tetraoxosulfate 6 solution by passing a current of 0.50 ampere. They have given you the atomic mass of copper to be this. Now let's see the steps that we should be using to get that. Remember the 3 points that I asked you to note. Now, if you check this question, what is given is they have given you the mass 1.5 gram, and they have given you ampere, that's the current. So now what you are looking for, they said you should calculate the time, which means you need this formula. And in this formula, they have given you current, which is I. You are calculating T. You don't have Q. The Q here, from what they have given you, this and this, you can use that to calculate your Q. Now let's start. Solution. I will first of all, since they said copper deposited, that means the copper was in the solution, which is Cu2 plus. Remember that When it is in the solution, it carries that charge, aqueous. Now, coming out from that solution, it has to collect electron. E minus is electron to give you Cu solid. Now, remember, this is 2 electrons that went out from it. So balance that equation. 2. So that the equation is balanced now. The charge is balanced. And from this, you can now see that 2 moles of electron is what is being used. But now, recall there, E, you multiply that by E, which is the value that E has, 96500, gives you or was able to deposit this mass because it's 1. This is the mass of this man. You say 63.5 gram. Now the mass that they are giving you there is 1. I will write it under mass. This is mass now. So I may choose not to write it. 1.6 gram. If I care, let me still write. So the quantity of electricity, this is that will deposit this, I do not know. And I use Q there. So now we are going to transfer that to this side. So by cross multiplication, if I cross multiply this by this, multiply the whole of this by this, I will now have Q equal to 2 times 96500 times 1.6 all over 63.5, and that gives me 2 times 96500 times 1.6 gives me 308,800 all over, divide that by 63.5, and that gives me 486229. That is 4862.9 approximately. I want to approximate to make it 3 here. Approximately 3. Okay, now this is for column quantity. So from here we are going to use this quantity to calculate the time using that formula that I gave you. Remember, I said Q equal to IT. Now, what is my Q? 4863 equal to I is 0, quantity, where's the electricity there? 0.5. 0.50 times T. And my T will be equal to 4863 all over 0.50. and that gives me 4863 divided by 0.50 gives me 9726 seconds. Okay, now let's go to question number 2. How many Faraday's of electricity are required to liberate 9 grams of aluminium? They have given you Al to be 27. Now let's see how to calculate. Remember, I told you writing of half equation is very important. Okay, and now solution. We are talking about aluminium here. To liberate aluminium from its solution. So Al is already in solution. Now we are trying to take it out by adding 3 electrons, write the half equation and balance it. And that gives you what? Al, solid. From here, you have seen that the mole of electrons that are needed to liberate this is 3. You have 3 times. Remember the number of I told you E minus is equivalent to 96500 coulomb. Now, that one liberates how many of these? 27 grams. Now, but in the question, they said 9 grams. I will put 9 under 27 because they are in grams. Now, this side, I do not know the quantity of electricity. So I will cross multiply. And I will now say this times Q equal to this times this times this. That means 3 times 96500 times 9 all over 27. So from this I can now use my calculator to say 3 times 96500 times 9 equal to divided by 27. I have my Q to be equal to 96500 coulomb. Work it out. And the question says what? If you check the question says how many Faraday, but I am getting in quantity. What I have there is quantity, but they are asking me Faraday's of electricity. Remember, I told you that 1 Faraday of electricity, remember this thing that I told you, E minus equal to 1 Faraday, which is equal to 96500. So if this is what I gave you already, that means that this is equal to 1 Faraday. So your answer is just to say, therefore, so if you say if this equal to this, then therefore 96500 equal to 1 Faraday. You have gotten your answer. Okay, let's go to question number 3. Calculate the mass of magnesium that would be deposited by 8 Faraday's of electricity. Magnesium equal to 24. This is JAM question 2015. Go there and check. You see this question. Some of these questions that I've been treating, they are from past questions, either JAM, WAEC, NECO, etc. So go there and confirm. Okay, now solution. They said calculate the mass of magnesium. You need to know how to write the half cell reactions. So magnesium ion will collect two electrons to become magnesium atom. Now here you have 2 moles of electron. That means 2 times what? 96500 to give you what? The mass of carbon of magnesium they gave you here to be 24. Now they say calculate the mass of magnesium. Magnesium you don't know. I can use X there. Now that would deposit this number of electrons. So I will now say 8 Faradays of electricity, 8 times 96500. I hope you are following. So now, after doing this, we are looking for X. You can quickly cross multiply this with this, and that will give you X equal to this times this times this. That's 8 times 96500 times 24 all over 2 times 9, 96500. Now work out the X. 8 times 96500 times 24 gives me, okay, 1852800 all over all over 2 times 96500. That gives me 193000. So if I divide this by this, I will have 1852800 divided by 19300. That gives me 96. 96. I hope I am calculating it. So is gram. So that's the answer to that question. In JAM now, you check option, you see 96 grams. That's the correct option there. So subscribe to this channel. I believe you are enjoying the lesson. Subscribe to it, share it, comment, like it, and keep following the channel. Thank you.